So as the as the last panel clearly indicated, these are exciting times in architecture and in life. And this is a fact that is not lost on students of architecture today. With the rapid and near total adoption of digital drawing and its increasingly sophisticated permutations by practice and education alike, the contemporary architect commands the most powerful analytic, production, and representation tools, arguably, in history. In an economy of sustained uncertainty, a single architect or a small cohort of architects are able to produce what in earlier times might have taken an entire office of many, many people to produce. And with the distance between design and fabrication shrinking, the architect is arguably has a stronger influence in the physical product that he or she designs than ever before. And yet, as so many speakers have mentioned, due to the alluring potency, the efficiency, and the ubiquity of contemporary drawing tools, creativity is as often unwittingly impeded by processing power, design obfuscated by image, and knowledge supplanted by information. As has been the case throughout the weekend, the final panel, entitled The Critical Act, assembles a group of 4 renowned practitioners who are all distinguished educators. Despite working in diverse methods, each has made a deliberate and dramatic use of drawing in their practice, and in so doing has established an unmistakable signature to their work. Following the last of this panel's presentations, Yale School of Architecture critic Sunil will moderate a discussion which we hope will provoke lively conversation and entertain your questions. And at the end of that, and then immediately thereafter, Mario Carpo, who is the Vincent Scully Visiting Professor of Architectural History here at the Yale School of Architecture, will deliver a concluding address. Due to the needs to change the tapes in our audio-visual recording, we're going to be taking a 10-minute technical break following the third speaker, Lynn, but we will resume immediately thereafter and proceed all the way through Mario Carpo's talk and recess upstairs for a reception to conclude the symposium. So I'd like to introduce our first speaker of the afternoon, Preston Scott Cohen. Preston Scott Cohen is the chair and Gerald M. McHugh Professor of Architecture at the Graduate School of Design at Harvard University, an emerging college in Boston. He is the principal of the firm Preston Scott Cohen, Inc. in Cambridge, Massachusetts, with projects of diverse scales and types, including houses, educational facilities, cultural institutions, and urban designs. He is the author of Contested Symmetries and Other Predicaments in Architecture and the forthcoming Museum as Genealogy, The Return of Nature, co-edited with Erica Naginski, and The Hidden Core of Architecture, a collection of theoretical essays. Ladies and gentlemen, Preston Scott Cohen.
Thank you, Victor. And, I'm sorry, George. I meant also to thank Victor, both of you, and Dean Stern. Thank you so much for having me from the University of the North. Okay, so rather than to proceed with the conjecture that the most radical consequence of computation has been the displacement of drawing as we had known it, it seemed to me to be more important today to assess whether or not other developments displaced drawing prior to the computer, and to understand what these mean for the most persistent forms of representation in architecture to this day. It is useful first to make a few observations about drawing. We should distinguish drawing as a medium of communication or picture making from drawing as geometric means to produce forms and thereby to serve as an instrument with which to define and construct the architectural project. Interestingly, much of architecture, even its plans and sections, has been conceived the way pictures are, directly, without the demanding regulatory principles and constraints of geometry. And yet, plans, in particular, imply projection the enactment of extrusion and sectioning. Thus, it is important to look back and discover the way drawing as a geometric tool theoretically redefined the convention of architectural representation. If we go all the way back to the origins of representation, we see that early plan drawing was executed directly at full scale. Gothic buildings were drawn on the ground with ropes. And what did the scaled plan drawing, the plan drawn with a stylus on wax tablets or parchment, represent? It represented neither the ropes on the ground nor the idea that the lines would extrude. There was no projective implication. The plan was already on the surface. It was all about allocating areas on the ground. In short, architectural drawing was not originally related to geometry. Only later would perspective, a foundational element in projective geometry, become considered to be an advanced form of drawing. What I will focus on now, and what is perhaps most important for the role that projection, as opposed to picture drawing, plays in architecture, is the foundational principle, as I said, of perspective projection, but in particular, sectioning. I would like to argue that with perspective came a profound redefinition of what a plan is. There is a world of difference between pre-perspective plan and the plan after perspective. From then on, plans are implicitly derived from cutting through as opposed to drawing upon something. And this is what makes them so much like today. It was during the Renaissance, of course, that we actually saw the principles of perspective formalized. The demand for realism and the alliance of mathematics and nature motivated the invention. Projection is, of course, a transference of three-dimensional points in space to a flat surface. It translates from 3D form to flatness, and the rays of light passing through points meet in one, the eye, which interestingly, projectively, is coincidental with the vanishing point. A slicing plane, and this is what interests me most, of course, is like a section cut through these rays, and it produces the matrix of points on a surface, which is a section, and ultimately a picture plane. And these points, when linked to one another, create a projection of a scene. In the 17th century, this changed. And what occurred is a description that brings into correspondence the representation of objects and the illusory distortion of these according to the idea of perspective. This is Desargues, who combines the sectioning of solids with perspective representation. And in here, we see that he has brought these two techniques together, the orthogonal and the conic projection, the parallel, and the conic. And in this way, the two finally are joined. And thus, we have before us a situation in which we cannot distinguish between the illusory, the picture, the object, the section. It's all in one system. And so one could say, with all of this behind us, the question of the conference today could be, rather than is drawing dead, could it be that the section killed drawing? I would say theoretically, yes, the section did do that, and practically no, or not considerably so until considerably later. Before, during, and after the age of perspective and section, buildings were designed and drawn in two dimensions, both in elevations and in section, and were assumed to extrude, but only empirically, not by projective means. With the arrival of paper, of course, and with Raphael's recommendation around 1518, The plan is accompanied by the representation of its elevation, but indirectly depicted as a pictorial elevation, showing two sides at once. The projective techniques were only used to pictorially represent preconceived ideas, or were used by the guilds for the purpose of constructing three-dimensional idiosyncratic shapes, units of construction. Projection then was synonymous with stereotomy, stone cutting. Now, something very interesting happens in a case like this, where the plan is built out by perspective, by Bramante, in a church that could not be realized fully, its plan, owing to the fact that a street ran behind the church. And so perspective is deployed in an illusory way again, but in this case, to bring about the impression of a centralized plan, compressed back to the section. In this sense, finally, perspective becomes a means to build the very plan that we understand the section cutting implies when we think through the principle from its origin. Probably the most important implication in the analogy between section thinking and perspective is that they share the idea that the object represented is in some sense a complete whole, an entirely new way of thinking that appears for the first time in the Renaissance. Architecture is preconceived. Following from it are the plans and perspectives that are cut, projected, and cut again. And yet this idea was not widely practiced or understood. A rare exception came in 1515 with Peruzzi, who used perspective to represent the plan explicitly as a horizontal section. Previously, buildings had only been partly cut away in vertical sections. It should be noted that despite the fact that it was perspective which was so formative to this significant change in the way the plan was conceptualized, it would only be used by architects for a very short period between the mid-15th century and the early 16th, when it was given up in favor of orthographic projection entirely. Meanwhile, the habitual segregation of empirical two-dimensional plans and section drawing from three-dimensional stereotomy continued, and the plan as section went unrecognized, and we can leap forward and see that Corbusier's plan as generator perpetuates this long-held habit of segregating the uses of section, reinforcing the concealment of the logic of sectioning inherent to the plan. With computer modeling, what we have is not the maturation, but rather the realization of a profound change that occurred with the brief period of perspective. Architectural space must keep stacking, however, and it would seem that until otherwise, its levels will still be accounted for in plans. This, not to mention the fact that the plan still holds sway at the drawing, as the drawing convention that correlates with the navigation of architectural space, something that the section does not do, the vertical section, that is. The computer has brought about overall building forms such as this one that do not extrude from two-dimensional originary plans at all. Clearly, the process has been reversed entirely now. We have three-dimensional forms full-formed, literally, not only in the imagination, before we make plans. And so, finally, plans and sections are literally results rather than origins. Now, there are buildings for which a plan is not only not a generator, but is anatomical. I call this type of plan anatomical since it is like an anatomical section. It should be noted that this extreme idea actually has, as one of its main progenitors, this building, a pre-computational building, of course, And we find here the idea most explicitly represented that the plan is of no particular consequence, insofar as one would think of it as a generator. The plan instead is more like, at any point in this building, a single frame in a succession of frames. And here, for the first time, we have the analogy to the filmic medium. Without extrusion, we have a continuously developing form of architecture in which any plan represents the principle of projective sectioning, finally, and most straightforwardly, which, as we have seen, superseded drawing long ago with the arrival of perspective. Just to be clear, though, we are a very long way, of course, from the time in the early Renaissance before Raphael, when drawings who thought above all in terms of plan would often find themselves somewhat surprised by the exteriors which resulted from their plans. Now the building is embodied fully a priori. With plans behaving as projective sections in succession, and in particular with the skyscraper, we recognize the changed significance of extrusion. If the filmic medium becomes a more apt analogy for architectural representation than pictorial perspective, extrusion assumes a new definition. A new definition exemplified most typically by this modern skyscraper. For extrusion, too, produces a continuously developing form, but not with a changing shape. Here we have a very interesting moment where a building turns into a very particular genre of film. It may be useful to take this analogy to an extreme and understand that if the Guggenheim is filmic, it is conventional narrative film, continuously changing and developing a form over time in a very particular way, and very linearly. But if the extruded skyscraper plans are slices too, then it is analogous to non-narrative film. And we could, just now, make a parallel, and this is a stretch and a peculiar one to make, but I think useful for this argument, to films like those of Warhol, and here we have Sleep, in which the content is radically reduced, becoming secondary to a fixed shape. That is, the figure almost not changing, fixed, at least in the mind of one who expects a narrative. Little changing from frame to frame, hours of inactive sameness as opposed to development. Warhol encourages distraction and wandering attention, and in this sense, clearly has moved film toward architecture. It is interesting to recognize that extrusion, the most typical formal attribute of modern architecture, that is, as it produces stacking, perhaps more than anything owing to the elevator and the steel frame, which we continue to have to deal with, despite all of the fluidity that Patrick seeks. Perhaps more than anything, this is what makes these radical avant-garde films more analogous to architecture, and much more so than the rare anatomical forms which, despite being prevalent in the academy, rare in the world, that is, those which actually are closer to conventional film, those forms that are today so popular that I'm referring to. You saw there the cutting plane of no consequence moving through the tower, whereas, of course, in the Guggenheim, we saw a development occur. Now we have something else, and this is the concluding point. Perhaps the essential distinction between the anatomical and extruded buildings, both which populate the imaginations of architects one way or the other, whether they like it or not, the essential distinction between them and their plans is determined by the concept of duration. Sleep demands the audience to endure the unendurable boredom of sameness in a medium that is expected to move and develop. Conventional narrative film precludes any recognition of the constituent frames that build its movement. Between these two architectural extremes, the anatomical versus the extruded, or let's call it the narrative versus the non-narrative, there is another model, the montage, which makes explicit the role of spatial successiveness, the stacking inherent to all of architecture after the skyscraper, as represented by the plans that pile up and do not change, and thus analogizes the cutting and editing that we have been talking about. The example of this in film, of course, the best of all, is Chris Marker's La Jetée, a dystopian narrative of time travel, which is composed almost entirely of still photographs. It is essentially a photo montage of stills variously paced with one brief motion picture segment. It is a series of sleeps. The closest architectural project to La Jetée is Koolhaas's Karlsruhe Center for Art and Technology, composed of discontinuous and differentiated plans. Inside the rather cubic building, plans populated by the vertical struts of Vierendeel trusses alternate with open plans to produce a stack of spaces that, like an architectural montage, evokes a series of radically different architectural types, arguably the architectural equivalent to time travel. This would include, for example, a kind of proto-hierarchical Beaux-Arts plan becoming Corbusian, a post-war Messian plan, evacuated, becoming bifurcated, a Thalos-like plan, a hypostyle-like plan, my favorite in the building, and back to Mies. And thus we have here a building that exemplifies, of course, his theory in Delirious New York, where piling, the slicing, piling up, is caused, of course, as we know there, by a culture he calls congested. Only the extrusion of the envelope maintains a constant that holds the disparate interior plans together, just as linear sequence, by definition an unassailable technical support of the filmic medium, holds together the stills of La Jetée. As a tentative conclusion, recall that the concept of sectioning and perspective projection once seemed to be an advanced form of drawing. But for architecture, projection now appears to have been the harbinger of an era in which the plan would be defined as one of a series of successive slices through the three-dimensional models and structures that truly govern architectural and spatial composition, that is, after it's been thought that way. As far as architecture is concerned, therefore, to the extent that the plan remains important, drawing has been dead for all intents and purposes a lot longer than the computer has been alive. Thank you.
Thank you, Scott. Our next speaker will be Marion Weiss. Marion is co-founder of Weiss Manfredi Architecture, Landscape, Urbanism, a multidisciplinary firm based in New York City, executing commissions nationally and internationally. Her firm has won numerous honors, including the American Academy of Arts and Letters Award, the Architectural League of New York's Emerging Voices of North America, and the New York AIA chapter's Gold Medal. Throughout her career, Weiss has taught at numerous architectural schools, including those at Yale University, Cornell, and since 1991, the University of Pennsylvania Penn School of Design, where she is currently the Graham Professor in Architecture. Her work has been exhibited extensively, and many people in this room may be familiar with her work, with her expressive charcoal renderings, which were among those exhibited in the 2010 Yale School of Architecture show, An Architect's Legacy, James Sterling Students at Yale, 1959 to 1983. Here to give a talk entitled Vanishing Points, Marion Weiss.
Oh, shitting, how do I, where is it, just here?
Yeah.
Thank you, George, and thank you, Victor, and thank you, Bob, for convening this great discussion about an obituary that has yet to be written. I think that the depictions and descriptions of death are inevitably there to elevate, if you will, the defense of the subject of such speculation. And for me, it's a luxury to actually scrutinize this point, really the vanishing point of the intentionally either-or query. Has drawing vanished? Has the infinitely expanding capacity of the digital paradigm displaced the efficacy of all other media? This question has a parallel, and it has a parallel with painting. And where the camera, if you will, threatened the critical importance of the somewhat imprecise media of the canvas, another either-or query that proved to be more complex was this one that said that oppositional overstatement was exactly that. So if the camera raised the spectacle of the painting's obituary, the painting of the potential of painting expanded in unexpected ways. So if we think about the fundamental nature of things that seem to reassert themselves even when their sort of imminent demise is stated, you would say that if one steps back a few centuries, then we can look at the Nazca lines here and look at this incredible inscription on the land and start to question about this desire to mark the land, a tactile resistant surface, with something that seems to have a perspectival convergence that suggests infinity. And it's these 2 points, the tactility, the convergence, the desire to shape a perception of owning more land than you could possibly imagine in one point, is where I want to step to. So if you see that, if we look at the vanishing point, there was a moment where it was a very simple thing. We all learned how to do it, and train tracks were the way. You could understand convergence. But if we step back a few centuries, the criticality of the vanishing point eluded painters, and by attempting to suggest depth and distance, the diagonal line and the diaphanous backgrounds implied the inhabitation of a territory where buildings and landscapes were infinitely larger than we could imagine in one paper. But the control of this vanishing point, if you will, to accurately depict depth and distance aided the representation of architecture. And architects, who were also painters and set designers, leveraged the compressed space of the stage set to suggest not only infinite depth to one vanishing point, but perhaps to a few, multiple vanishing points. So you could say that the distortion necessitated a precise location or station point of the implicit picture plane to allow the panoramic access to the multiple vanishing points, and the single vanishing point with the converging diagonals in the center shifted over when the diagonal came into play to something far more complex. In fact, you could say that Alberti in 1435 had advertised the perspective method in his book On Painting, and that how-to was extraordinarily influential. But perspective has been a suspect tool, and a critical voices of the Renaissance, while generating more precision in the potential, observed that it was a deceitful practice, always distorting true measure. So Piranesi was a very skilled man in many ways, but also a skilled theater designer among his many talents, and he took liberties with the vanishing point, and the act of drawing actually inscribing an etching tool into the surface of the metal, again resistance, to suggest a more indeterminate, more simultaneously, ultimately incomprehensible territory of infinite and inescapable depth. His etchings evolved in some cases with additional layers of etching, some superimposed over the plate nearly 25 years after the initial first stage. I find this very interesting. These additional excavated layers subtracted from the surface added intensification and additional elements, a thickness and tactile expression to the depth afforded by perspective. In fact, the Piranesi effect of consciously created confusion was more aspirational, suggestive, emotive, ultimately inconsistent, and unconstructible projections. But these perspectives were never sedentary. They were in full motion, providing incomplete but compelling promise. Now, the impulse to represent the infinite inhabitable potential of the vanishing point was captured in the God that everybody worshipped when I was in school and continue to worship. But you could say that here he had a different idea, one where the vanishing point wandered off on the horizon, and it made its way into some infinity, which was that drawn line again on the land, but finally thickened and inhabitable like a contour. So as a student here at Yale, the emphatic monumentality of the drawing reflected the climate of the time. Sterling and other modernists were changing the way we were seeing things, and in the axionometric, summarizing the totality of buildings, diagram, and idiosyncratic massing all at once, was the ultimate expression of invention and control. As students in Sterling's studio, we understood the necessity of the fully measurable, impeccable, ink-lined organizational authority, the airily disposed axionometric, or, in this case, a Schwarzy view, and we knew that this would be the necessary pinnacle of our studio project. I was maybe a little more taken with the building we were in by its kind of sectional clarity and Rudolph's incredible sectional perspective drawings. And so you could say that I was not a good compliant student in Sterling's studio, because while it was easy to emulate the axionometric axiom, I felt a certain dissatisfaction in the distance between the precision of the inked drawing and the tactile impact, and in the certain boundaries of the charcoal drawing. And so I did my ink drawings, and I hated them, every one of them. My project was fully measured. And so I returned and was reluctant ultimately to commit to the precise line because I didn't like the way it looked. I had not yet been able to rouse my own enthusiasm with this axionometric axiom. And so the penalty of procrastination were these drawings, which I was trying to get at something that was not quite real, not quite there, not quite inhabitable, but fully inhabitable and simultaneous, and somehow momentum of territorial expansion was something that I was trying to claim. So you could say that it was a challenge, because if you look at what it means to start to think in more parametric terms, you could say the pre-parametric, which Scott Cohen pointed out so eloquently earlier, was something that Michael Manfredi and I, because we draw together, and you'll see some in our presentation that we've shared, the idea of somehow messing with or noodling with that territorial clarity and crossing those boundaries has been a preoccupation. This messiness or dirtiness is a point I want to make. Jasper Johns in 1979 talked about how much he liked to do a drawing, do it again, and do it again in a different media to see what he would discover. And every time he would discover something different, that resistance would offer a new discovery, and sometimes that discovery would go to white. Sometimes the numbers, again and again and again, would become so compelling to him that he had to make tactile sculptures and surfaces some 25 years after those drawings were made, not unlike Piranesi returning to his etchings, create something that's so tactile and measurable that it is indeed physical, almost architectural. So I taught a drawing class at Yale when the parametric paradigm started, in a sense, ascending, and I wondered whether it was possible to sustain the uncertainty of the hand drawing and then the wet media on plastic, and then actually use the computer to distort, amplify, intensify, and make new discoveries. So by using very simple drawings and photographs, those would then go into another wet media on plastic, which Jasper Johns so loved, and those could then be intensified in digital terms to be translated into things that might sustain a more tactile kind of haptic world, or in fact actually become something impossible to say the kind of two-stage perspective that might start to change over time when media gave it new insights, new light, new amplification, and intensification. So all this is to say that these preoccupations of never finding a finishing point to the vanishing point gets to the surface of our work. And in our work, for instance, at the Barnard College Diana Center, while we had a very spatial idea of the diagonal to connect and allow insights to be seen simultaneously, we also wanted to break down the hard surface of a glass box and consider the spatial connections that we might see through that glass box in conflated, compressed ways, oblique ways, but that the surface itself was something that we wanted to think about. And so the drawings or the sketches in charcoal, we love the indecision of them and the indifference to the finish line, and try to sustain that indifference in the surface of the glass. So the Frit pattern took the sort of whisper of the charcoal, and then the acid-etched glass, with about a year of experimentation in Germany, of externally acid-etched, internally color integral, spectrally selective glass that we tested in different ways, could actually, with the back pan 4 inches behind that glass, share the luminosity of either red or copper, depending on the light, and always change and never stay fixed in chroma. And so that kind of collaboration then with the tactile surface of the charcoal drawing and the tactile thing then needed to be analytically taken forward with a kind of sectional, sequential, connective identity that could change, connect, bring forward, and ultimately take that notion that was indecisive at one point and conclude with something more precise. So this exercise, if you will, is under construction right now at Penn with the nanotechnology building that we're doing. And there is a case that wants immense precision because it is indeed all about incredible stabilization structurally and also no electromagnetic interference. So how do you take the instability of the charcoal drawing, the gesture of the perfect concept plastic model, the indecision again of a cardboard model, the slightly more decisive discussion with the client, and then maybe the great precision the parametric tools have given us to actually realize something that can move around, allow us to spatially create multiple vanishing points and sequential movement under construction now last week, and start to envision what it is to inhabit something that makes you pull forward, feel the kind of tactility of these vanishing points, and imagine the kind of transformation of a space that might open up and shape a new landscape, and if you will, inscribe its way onto an urban surface. And that inscription then with the Museum of the Earth in Ithaca, New York, is now topographic, and the etching and carving into the land and the convergence, if you will, of topographical and topological change is tied to the kind of experiential first impulse collages that then allow us to start to imagine what it is to take those things more precisely into the earth again, sequentially, sectionally moving, and starting to look at the gathering of water and the convergence of something that might collect water to then take that Nazca line again and to make that site look substantially larger while it's doing an operation that collects water and inhabits the site in a completely different way. And this inhabitation then currently under construction, the Botanic Garden, Brooklyn Botanic Garden, is something again where the idea of Olmsted's wandering paths and the idea of a kind of softened topography were these instincts that we had when we thought about the city entry into the garden. But then there's a kind of wild sketch of what happens when you sort of say, all right, we've got parking on one side, we've got movement, we've got security, we've got topography, we've got section, we've got water collection, we've got all these things. And then the distillation of these things has to go through a rubric of sequential sections that change and go from urban to something that actually just joins the land. And so these kind of loose toggling between wandering lines and wandering lines again, or the inhabitation of the edge of the garden, or maybe two distant vanishing points on either side, or an inhabitable topography that might be softer in surface than what the parametric steel plan allowed us to do, could be so soft, in fact, that maybe the sensuality of that sketch line and the topical surface of the charcoal drawing could come together. So in Seattle, this question then of what it might mean to just collage a new topography onto the city, and again, that rough anger of, oh my God, it has to do everything all at once, remediation, speed, movement, sectionalization, salmon habitat, surfaces for art, etc. All those layers need to be analytically, totally, organizationally, including contamination remediation, have to be thought of in layers, sexually, topically organized. And so we're always thinking about this kind of cinematic potential of lateral contours and vertical sections simultaneously being conceived to allow us to see things in ways that would allow us to imagine a constructed topographic landform that could ultimately connect two disparate parts of the city. So a kind of strange conflation then of sketching, thinking in section, and sectional perspective to the making of this kind of convergent line, these kind of angles trying to enlarge a site that's actually tiny, only 9 acres. And all these kinds of diagonals then allowing an embrace simultaneous of roads going through it, under it, over it, across on the horizon, and this kind of mix of media simultaneously in our thinking has been the kind of cast, if you will, of our preoccupation with the kind of layered intensification and aggregation, if you will, or condensation of a bigger world, like a theatrical world in one very finite place. And so this sort of sense of movement, and movement again is what I'll invoke in this kind of closing animation that will follow this the sense of movement, simultaneity, multiple sort of theatrical sets that we might get to, leads to a fiction that if we could start the animation just now, I'll close with a few observations if indeed the animation is animated. So I guess it's that dirty secret, if you will. It's the native potential of different media, the intensification, if you will, from repetition, from doing it again, trying it again, and doing these superimpositions to intensify through repetition, etc., the potential of something, sort of irritating little point about what it might be. And so all these combining of tools, the kind of distortions, the effects, the surfaces, the potentials, the movement, the cinematic, all of this, in a sense, suggests to me that it's a fictional finish line to say that drawing is dead. That somehow the iterations, scenarios, and options from the charcoal sketch to the digital frameworks to the surface effects, that somehow the back and forth of these medias, including digital media, allows an approximation that allows us to postpone conclusions, but to somehow enrich our process along the way. And so, if we say that the kind of soft indecision of the material of the charcoal, for instance, could change this building's thinking from a hard glass into something else, we could say that even with Seattle, then the real vanishing point starts to touch on this issue of the premature obituary that I think has been read for this conference. Because if the point of an obituary is to summarize in short order the virtues, contributions, and the impact of an individual that is suddenly gone, usually the glowing setting aside of the weaker moments is what obituaries do, and they have a curatorially polished, if you will, selection of milestones to let us know what was great, but what is gone. But for us, the promise now, with the glow of the digital paradigm, if you will, casting shadows over 6 centuries of drawing, is not saying that it's over, but in fact is giving us a moment to leverage the opportunity of the simultaneity and the capacities of all these medias somehow to draw out what is yet to be imagined. So I'd like to say then that my final point, the vanishing point, if you will, is that there is no death to drawing, but there is only maybe infinite richness in that vanishing point that's beyond us. And that in this framework of media, in motion, testing sequentially, that somehow all of us have yet to draw something that we have yet to see. Thank you.
Thank you for a wonderful talk, Marion. Our next speaker has asked me to abandon the introduction that I was going to give him, which I will do. But I must say that probably familiar to all of you, Greg Lynn, his work has been recognized as pioneering in the world of digital drawing. We are lucky to have him at the Yale School of Architecture, where he serves as Davenport Professor. And without further ado, Greg Lynn.
You can leave the lights up for a second. Well, first, I'm a little embarrassed because I actually brought drawings, and the drawings that I'm going to show you were not meant for you to ever see. They were really just for me, but I thought it would be interesting, so indulge me. They certainly aren't as beautiful as a lot of the drawings we've seen today. But I do have a few comments before I talk about some technical issues with drawing. I think the first thing is I would like to make a statement that I don't believe I can substantiate, but it's that there's a difference not between drawing and computation, but I'd say there's a difference between drawing and drafting. And I don't know quite where sketching falls into all that, but I actually believe that drawing is associated with the critical development of a project, with a critical attitude towards a project, and a design approach, and it usually precedes drafting. So innovations in drafting will follow innovations in drawing, but I believe that spatially anyway, the way I think is through drawing. And drafting is always tracking it. I mean, drafting's important because it's descriptive, which I think Scott talked a lot about, the descriptive power of it. It also can involve expediency, accuracy. I mean, Andrew had some awesome comment where high fidelity of 3D models. I mean, I think these are all things that I associate with drafting and mechanical procedures. Now, the reason I'm trying to make this distinction is I believe that in this parametric moment that there's a drawing attitude and an optimization and a freedom of managing complexity, but I also believe there's a drawing component to it that's very important. So I wouldn't make any distinctions in scale or precision or even technical method or media between these things, but I think the distinction's important. So the real difference is this creative versus, let's say, managerial quality. Now, the reason I'm saying this is I'd be a little troubled if we left today with the distinction between sketching as a conceptual and creative act and computation as a implementation of that or a management of that. I think for me, the digital medium is much more important than that. I know that the sketch, the pencil sketch or the pen sketch, everybody was kind of proudly holding up their pencils and pens yesterday. It signifies an area of expertise. I think I could probably hold up a mouse and say that I use my hand on a mouse instead of a pencil in a way that it also cuts to the point. I mean, I was watching Julie's presentation today, which was amazing, but I was thinking to myself, oh my God, I would have to spend like 2 weeks learning how to use that sketch program. That's like so cumbersome compared to how I sketch with a computer already. So, and I'll show some examples of that. So anyway, the other thing I'd like to say is that there is a disruption in any field, especially design fields, but really any field, manufacturing, all kinds of fields, when a new technology comes into the discipline. The previous knowledge, the habits, the methods that made up intuition, critical intuition, and intelligence have to be rethought when these new technologies come in. Doesn't mean that they replace them. It just means you have to adapt and define a new medium. And I think really where we are now is at the point that we can maturely claim that digital technology is a medium. It's probably the first time. I've been using it maybe 25, 30 years. But I think now's the time it's a medium. That's why we're having a conference on drawing and digital technology as a kind of subtext to that. So it's a continual process of the introduction of tools, but digital design and manufacturing, talking to machines, constitutes a pretty radical rethinking of our drawing medium today. So geometry maybe has changed, but I really believe that the medium by which we describe these geometries has radically changed. So this excitement about new potential, which I had 20 years ago, I realized pretty quickly there was a downside to it, which is everybody in the field becomes an amateur. Like the minute the new technology comes in, we all don't know what we're doing anymore. And you used to hear a lot of words like experimental digital design and things, which was just an example of the fact that nobody knew what they were doing. I've used this example of the Ford Taurus when Lee Iacocca said they were going to do, he called it no more over-the-fence design, meaning the designers would throw a design over the fence to the engineers, but that they would try to compress the design process from 6 years to 2 by having everybody use computers. And what happened with the Ford Taurus was the second generation Taurus was the first car to be designed with Surface software. And the poor designers didn't know how to put a door handle on it, rear view mirrors, was a blob. They called it a blob. What was most alarming to me was that critics, cultural critics and theorists took the torus and turned it into a design icon, as if this kind of barely articulated blob of a car designed by amateurs was the future of design. And the reason they did that is because they didn't understand what was going on. So what's more troubling to me than the loss of facility that comes with new technology is the loss of critical and theoretical knowledge in the institutions that are training these people. So, I mean, nobody acknowledged that we were a bunch of amateurs 10, 20 years ago. And what I found is that journalists and cultural critics and even historians and theorists are too quick to apply old standards to these new mediums and new technologies. It generates a lot of confusion. So the amateurization of a field by taking away its facility with drawing tools and replacing it with new tools sets something up where the critical community is always tracking and behind the designers rather than leading them. And I think that's something I've witnessed today, to be totally frank. I mean, I was knocked out by Andrew Witt, who I thought was the chief technology officer, but is the director of research for a computer company. Gave the most profound historical and theoretical talk of the day, and the historians and theorists, I'm sure, weren't aware of any of that stuff. So it's really shocking to me, the gap between the designers and the historians and theorists. And for me, I think the task isn't so much rethinking drawing, it's rethinking the history and theory of drawing. So anecdotally, Antoine Picon said to me, you know, it's funny, all the PhDs that do their dissertations on drawing never complete. So it's something for the historians and theorists to think about. So the disappearance of critical journals, theorists and critics from our field, and a loss, I think, of discourse coincides with this introduction of digital media. And I think it's just a fact of our field and needs to get fixed rapidly. Okay, so to kind of get to the silly anecdotes and drawings, which I'm trying to avoid showing you. I think instead of saying that drawing is dead because of the loss of the sketch, what I'd like to do is show a couple of examples of how I like to use digital technology the same way I use pen and ink drawings or constructed drawings. I brought stuff from over 25 years ago to show you. I think that I'm doing this to show two things. The first is that there's an anticipation of the computer in drawings that made the computer happen. And I actually believe, and this is just because it's my personal experience, that it was the New York Five that generated the need for the computer. The approach to form, as well as a kind of Palladianism espoused by Colin Rowe. What's that? I don't. No, Michael, feel free to leave the room for the next half hour. What you need to know is I always am holding my hand up saying I'm a student of Michael's. He still hasn't claimed me yet, but we'll see. But anyway, I believe the New York Five and the education that I got under and being mentored by members of the New York Five was really what was pointing me towards digital technology. And I think digital technology didn't just happen. Contrary to yesterday's comments, it was actually developed by the architects. And it was developed to satisfy a need that was already being anticipated. So that's the first point I'd like to make. The second is that I think there's an assumption that you can't sketch with digital technology, or that it's so cumbersome and accurate that it takes a long time to sketch. And I'll show you some examples of, quick sketching with the computer. But what's funny is when I draw with a pen, it's always something I do after I've sketched with the computer to kind of clarify it and simplify it. And frankly, it takes me a lot longer. Like I can model something much quicker than when I draw it to clarify it. I'll show you some examples of that. So I guess now we can dim the lights. Okay, I don't know why. This would probably be for an analyst to figure out. I've always hated these things. No, just because they're so flaccid. It's also impossible to get wall thickness with these things. I actually went to Princeton to learn how to draw these. This is a thing that I whipped up actually on the way over here. But it's a composite curve network, which is made out of a series of radii. And the reason I wanted to learn how to draw it is because you can offset wall thickness with it. Whereas if you use one of these things, it's a nightmare. And it's very inaccurate. So and you can also change regions of a curve network like this without having to change the whole thing, which you can't do with a French curve or you can't do with a flexible curve. So I went to Princeton because I knew Michael did the Snyderman house, and I wanted to learn how to draw those curves up there in the Snyderman house. And what's funny is when I got there, I found one of these mechanical splines. There was a German student who I don't remember, who was 2 years older than I was, who had one of these things. And this is 25 years old, so I had 3 of them. I tried to unroll one to take a picture. It fell apart. But there's a rubber profile with all of these discs. It's a very old drafting device, and it's called a spline, and you draft coordinates for the discs and tape the discs down, and you can make a spline curve. And it comes from the shipbuilding industry, but civil engineers were using them like crazy. I got to Princeton and found these. I don't even know if Michael remembers, but it was like a virus. All the students had these by the time I graduated. What was interesting about it is it turns a curve into a series of infinitesimal line segments rather than being arcs. They're all little short straight lines that are just smoothed with the spline curve. After Princeton, I went to work for Peter Eisman, and Peter at that time was doing curvature without curves. This is something for Peter's analysts probably. But I spent, you can see these are, I believe, I'm haunted by it, I think 130 blocks that are rotated in plan and section, 3 stacks high. Also the Frankfurt Biocentrum, which came before this, did a very similar thing with arraying profiled elements along curves, but without actually using curves. At this time, there was software to array these things. There really wasn't software to work fluidly with those elements. But one of the things I discovered with this ability to make curves out of incremental line segments, which is what a spline is that there's the curve and there's the normal, which is the line that's perpendicular to the tangency of this virtual curve. When I left Peter's office, another anecdote, don't let Bob Somel pick you an apartment in Chicago. He found me an apartment in a building which I found out was for blind people. So I was in this little room. It's a kind of Barton Fink era of my life. And I spent maybe a day building this model of the Sears Tower laid down for a show Stanley Tigerman was doing. And then I spent 3 months, maybe 12 hours a day, drafting all 110 floors of the Sears Tower, first rotated in plan, and then projected in section and rotated in section, and then projected back into the plan and rotated in plan, and then back to the section again. There's 9 of these tubes. But so I produced these drawings over, incredible amount of labor to then use MicroStation, which was the first program that had spline modeling tools. A couple years later, I did this whole operation in maybe 15 or 20 minutes by just animating blocks along paths. So I think, I'm I'm the oldest person that models with the computer, I believe. I've been looking around to find somebody older, at least who's been doing it longer. So I'm like a T-Rex. But anyway, these things, I'm glad I did this. I wouldn't have thought, every day when I animate something along a path, I actually remember the labor involved in not doing it, but I also understand the principles and the projective geometry of doing it. Anyway, but so this idea of incremental sweeps and animations, this was also for a competition for Cabrini Green, where I manually drafted each one of these elements moving with an adjustable triangle. So, I mean, obviously I was waiting for the computer to be able to do this for me, but before there was a program for me to use, I was already thinking of this kind of, I mean, now you would call it, an array, but incremental change in gradient. But so, it's just to make the point, all of this stuff was being anticipated before it had arrived. It's not like it arrived with a shock. It kind of was a welcome thing for me. I'll show some more examples. These kind of branching diagrams were also, these are drafted. This was for the Cardiff Bay Opera House competition. I don't actually even remember the date of that. But this was a thing where I was just branching these based on a thing called Bateson's rule and changing the scale with every iteration and branching. And you'd now call it some kind of procedural modeling. As well, I mean, now if you use subdivision surfaces and things, you're using an algorithm by Chaikin that smooths corners. But at the same time, I had this idea where the volumes, when they were small, would be have less resolution, like four-sided, and I would knock corners off of these things every time they got bigger and bigger and bigger. So, and then after the competition, so these were all manually drafted using those branching rules and the smoothing rules, and drafted in section as well. And then maybe a year after the project was done, we actually modeled it on the computer. But again, all these operations are operations that now we understand as being part of digital technology, but really were anticipated before it had ever arrived. That's the rendering of it. Okay. Now, I think once this software was available, I started to sketch with it. And sketching with the computer at first was, it involved learning the medium, but actually I've never found it not to be expedient. Not to be as expedient as a pen or a pencil. These were real early studies with a blob modeler from a program called Wavefront that we used with Doug and Mike for the Korean Presbyterian Church. And the logic of the model, here, which were very kind of randomly placed, ended up following the rhythm of the structure of the building, ended up, kind of informing the way that it was modeled as a surface with these offset planes, and fairly directly went into the logic of the construction. But again, this was a project which was sketched entirely digitally. We don't really have any hand sketches of this project. And I have to say, for a long time, I quit doing a lot of drawings. This was maybe the first drawing I could find, which was, I think, 2 or 3 years later, which was a little diagram for the Arc of the World in Costa Rica, this visitor center. And it was trying to work out an idea of lofting, where there was one set of curves in this direction that you'd call a path, and another set of curves that were profiles. And you can see these profiles are just, I actually animated the profile and then swept that animated profile along that path. You get a massing like this. But in this case, it was really a sketch that came before the massing. And more I started doing sketching, and what I found is that I was kind of sketching for the computer. Like what I was drawing was really drawing the way things would get modeled, and even putting little dimensional notes the way things would get modeled. And again, these things are not really for like popular consumption. There were more things to either, not really to fax back to the office, but just to clarify things. This was a funny little anomaly I found. I turned off these things called curve loop cutting. The surfaces were folding through themselves and making some problems. I turned off this tool and found these things that industrial designers were calling blebs, but it's where a offset spline, where you offset thickness for a spline, it folds through itself. And for the IB Museum, I use this as a kind of facade idea to take the skin and fold these cantilevered exhibition spaces out to the street and then fold the auditorium into the facade and fold the lobby out to the street. And you can see these little diagrams were before, it was a little bit during the modeling, but it was to clarify the massing. But anyway, these started to look more like things from the computer. These are the kind of controlling curves of the skin. And just some very quick renderings of it, a little study model. You know, it was also around this time that I bought a laser cutter and a CNC mill and did, again, what Andrew started, what he mentioned, which was machine legible design, which I thought, high fidelity machine legible design. That, if you don't mind, I'd like that to be my new moniker. But so I then started to think through how to talk to machines that are fabricating construction elements. So for this little study for a house, which I remember I did at the conference for Michael's retirement at Princeton while Hal Foster was speaking. I remember I was sitting in the audience and did this little doodle for a structure because I didn't have a computer near me. But the idea was that the structure of the house is built out of one continuous rolled tube that would float the house. I'd just seen the Lina Bobardi house. And from this diagram went directly working with Robert Aish at MicroStation with building a little parametric tool that again would build all these tubes as composite curves because they needed to be radial curves. So instead of drawing a spline and converting it to a radii, these start with the radii, and you can see you can move elements around. They automatically, there you could see this composite curve drawing. Okay, the other kind of drawing tool that I find very powerful and useful are expression tools. Really, they're the basis of what now people call parametric modeling. I started using them from tools that were built into CAD software for animators to try to attract animators to digital technology. For this Alessi coffee set, you can see there's a series of 8 or 9 curves, which I just designed for how you'd grip the pot. And then by combining those 9 curves in 4 positions, we came up with, you know, tens of thousands of options. For the flatware for Alessi, very similar approach. I've shown this before here, so I'll just show it real quick. I designed a primitive, which could be a fork, a spoon, or a knife, and then gave it traits and used animation software to blend between these different traits. Here's some of that flatware as it's produced. But again, you start with a primitive and you vary it. But for me, the ability to sketch these forms using animation tools is what was important. And then finally, for me, a logic of surface minimalism, let's say, which I now know is going to be very big with your occipitotemporal lobes. What it is that it's a logic of using spline surfaces to integrate components and parts. It really started with products. This is a little sketch, the very first sketch I did for the ravioli chair, with the idea that there's a hard surface that does everything that legs and a base would do. And there's a soft top surface that does everything that the arms and the seat and a back would do. So you'd really integrate all these components into 2 spline surfaces they would take care of all this. One hard, one soft. That's the finished chair. The Alessi supple cups. I mean, this is really where I'm drawing for computer modeling, but a container to keep liquid hot, and then a skin, second skin, which you grip. And all of these points are kind of defining the limits of splines and how they would vary and get lofted to produce these volumes. What's very funny is I hadn't even looked. This is like the worst drawing I ever did, so I'll move it. But the first model I did for the Bloom house was actually this set of 5 surfaces that were very quickly lofted. I believe this whole process, I looked at the times and dates of the file, but these are 10-minute sketches. They're really very quick little sketches to kind of get the massing on the site and see options. There were 4 or 5, but this is closest to the finished house where there's this kind of open corner. This top surface and bottom surface bite together to form these kind of eye shapes. This open front with this hanging lantern. I mean, it's very funny. It was kind of all there nascently in a little 10-minute digital sketch that then we could quickly render. And it was really the diagrams and the drawings that had to catch up to that. And sorry to just jump, but I mean, you can see that a lot of the basic moves, that corner, were there in that very first digital sketch, which is where the first ideas for the house came up. And this is that kind of surface minimalism. This is that thing that part of your brain would love, because there's no fireplace sitting there. There's just a space that swallows the fireplace. Same with the bathrooms. Toilets and sinks and everything all get kind of absorbed into this wet wall. Okay, very last thing. What I'm playing around with now are these coplanar details where 2 materials occupy the same surface and get laminated up into these sandwiches. And this is something just to show you, don't know how to sketch yet, but go very quickly to with the computer models. The future, I believe, the thing that's happened to me, I remember with the Port Authority project, which was the first animation sketched thing I ever did, I had to set up something in the computer, hit enter, and wait 12 hours for it to give me a result. And I haven't had that experience for a while. And I started using computational fluid dynamics because I'm interested in the design of moving objects. And not only the fact that you design these things in a fluid and shape them in a fluid, but also that when they sit still, they have to look like they're moving. And there's a naval architect who now is working in my office full time, and the 2 of us have been playing around with using this computational fluid dynamics. And this is something where we send a file to a 60 computer cluster, and it takes 7 days to give us something back. Once we have it back, we can visualize it and move it around and look at it, but it's really, really slow. But all I can say is that when it gets real time, which it'll do very soon, really changes the way you think about space, because you're designing in a space which is active. This is a trimaran that we're just starting construction on. You can see it's actually the first object that's ever been modeled in both air and water at the same time. And the one example I'll show of how this modeling in a fluid dynamic space has changed the way we design. First is, I don't know that much about boats, but I just do stuff and we put it in the machine and see what the consequences are. The naval architect has an intuition about it, but so what this boat wants to do, because it goes 25 or 30 miles an hour all the time, is it wants to flip over end and bury its nose. So one of the things we did is we get back images like this. This is what's called flow separation, which is a bad thing. We try to minimize that with styling and the surfaces. But I came up with this chine and this fold in the bow. It turns out when it dives, this helps it to lift back up out of the water again. So what's great about this is you're putting forms into an analytic matrix of flow. You can experiment like an amateur, but it gives you back performance information, and it really changes the space you're sketching in. Because for the first time, the space you're sketching in is actually moving with force and direction, which for me is the most exciting thing I've ever come across with a computer after 20 or so years. And this company that's doing this work actually primarily focuses on super tall buildings. So they're already deep in the architecture world. So thanks very much.